Hello and welcome. Let's go to section 2, question 17. You're supposed to answer any 5 questions from this section. 3 consecutive terms of a GP are x plus 2, x minus 2, and x minus 5. Find the value of x. You're supposed to find the value of x. So because you're given that this one is a GP or geometric progression has a common ratio. And you're going to get the common ratio of these 3 consecutive terms like this. So the common ratio, you're going to get x divided by 2 divided by x plus 2. That is a common ratio, and it should be equal to x subtract 5 divided by x subtract 2. So this represents the common ratio. That value should be constant for these two. Now, for you to get the value of x, you simply need to solve this equation, and you do this by cross multiplication. So x minus 2 multiplied by x minus 2, that will be x minus 2 squared is equivalent to x plus 2 multiplied by x subtract 5, like that. So this one will give, when you expand x minus 2 squared, this will give x squared minus 4x plus 4 is equals to, when you expand these, x plus 2 multiplied by x minus 5, you'll get x squared minus 3x minus 10. So from there you can solve for x. You can see you can subtract x squared from both sides, such that you remain with a negative 4 x plus 4 is equals to negative 3x subtract 10, like that. Like terms together, so for x, you have negative 4x, then you bring this onto this side, you have plus 3x is equals to, take positive 4 to the right hand side, you get negative 10 subtract 4. So this gives negative 4x plus 3x, you get negative x is equals to negative 10 minus 4, that will give negative 14. So dividing both sides by negative 1, you get x is equivalent to 14. And that is the solution. Part B, find the common ratio. Remember, the common ratio can be given by either these or either these. So you can choose one. So I'll choose the common ratio to be x subtract 2 divided by x plus 2. And this gives, since you have the value of x, you just need to substitute. So this x minus 2 will be 14 subtract 2, then 14 plus 2. You're just substituting the value of x with 14. So this will give 12 divided by 16. And when you simplify this, you get 3/4. We go to the next part, part C. Given that x plus 2 is the third term of the GP, find 1, the first term giving your answer as a mixed fraction. Giving your answer as a mixed fraction. So given that x plus 2 is the third term of the GP, so how do you write the third term of the GP? That term is given by a r raised to power 2. Remember, the nth term of the GP is given by a r raised to power n minus 1. So if you want to get the third term, you simply substitute n with 3. So this will be AR raised to power 3 minus 1, that is 2. So that is the third term. And from these, since we are given the third term is, the third term of the GP is x plus 2, we can get that, which is, so this is x plus 2. And since we have the value of x, you just need to substitute. X is 14 plus 2. So this gives 16. So the third term is 16. So that one will help us to get the first term. The first term is A. Remember that A is the first term of the GP. So using that now, we can say, because we have that term as 16, the third term, which is AR squared, is equals to 16. So we have A, we don't know that, but we have the common ratio. The common ratio, we obtained it in the previous part, is 3/4. So you just take 3/4 raised to power 2 should give 16. So A, therefore, A will be given by 16. You divide both sides by, this is 3/4 squared, like that. So this will give A is equals to 16 divided by 4 squared. 3 squared is 9, then 4 squared is 16. Denominator had not squared that. So now we can proceed. So A will be given by 16 multiplied by, we have the reciprocal of 9/16, which is 16/9. And this will give 16 by 16. You get 256 divided by 9. Now you're supposed to leave this one as a mixed fraction. So as a mixed fraction, when you divide these, you will get 28 and 4/9. That is the value of the first term. Part 2, the sum of the first 6 terms correct 2 decimal places. The sum of the first 6 terms. So these are the first 6 terms of a geometric progression. For geometric progression, you have 2 formulas for obtaining the sum. One is when r is greater than 1, and the other one is when r, or the common ratio, is less than 1. So in this case, the common ratio, we got it as 3 divided by 4. That is less than 1. So if it is less than 1, the formula that we use is going to be given by this 1 minus r raised to power n divided by 1 minus r. So this is the formula that you're going to use. So the sum of the first 6 terms be given by S6, that is the A is the first term, which we got as 28 and 4/9. So you can write that one as an improper fraction. 28 and 4/9, you can write it as 256 divided by 9. Then brackets, we have 1 minus, the common ratio is 3/4, and 3/4 is the same as 0.75. So I can write 0.75, that is 3/4. Then you raise by, remember, if it is a sum of the first 6 terms, n is equals to 6. So n will be 6. Then you square, you close that bracket. Then 1 minus, common ratio is 0.75 raised to power 6. Not raised to power 6, but just 1 minus r is 1 minus r. That is 1 minus 0.75. So that is what you're supposed to do. And at this stage, you can simply use your calculator. So use your calculator very well to work out these. So we can simplify it. So using a calculator, so you'll get, this is 256 divided by 9, and then multiply by, so we have 1 subtract 0.75 raised to power 6. So that gives 0.822. Like that. Then everything divided by 1 minus 0.75, that will give 0.25. So when you feed everything now in the calculator there, the way it is, you will get 93. You get 93, 197 divided by 375. Since you are required to give the solution correct to 2 decimal places, this one is very important. I not notice that one. Correct to 2 decimal places. You can leave it as so this will give 93.53. 93.53. That is correct to 2 decimal places. You should be very careful with that accuracy mark. In case you leave it like this as a mixed fraction, you may not score the answer mark. So you must ensure that you leave it in the format that is required. So that is how you're supposed to do that question. Question 18. A Form 1 stream at Butere Mixed Day Secondary School has 15 boys and 25 girls. The probability of a girl reaching Form 4 is 2 over 5, and that of a boy is 3 over 5. If a girl reaches Form 4, then the probability that she gets employed is 2 over 3, while the probability that a girl gets employed without reaching Form 4 is that. If a boy reaches Form 4, the probability that he gets employed is 3 over 4, while the probability that a boy gets employed without reaching Form 4 is 1 over 4. Part A, draw a tree diagram to illustrate the information above. Draw a tree diagram. So we are going to start from the first statement here. In this school there are 15 boys and 25 girls. So boy, girl, first branch. So for the first branch we have boy, girl. So since there are 15 boys and 25 girls, the probability of picking a boy will be 15 divided by the total 15 plus 25, that is a 40. That is for a boy. Then for a girl it will be 25 divided by 40. When you simplify these will give 3/8, and when you simplify for the girl, probability of choosing a girl, these will simplify to 5/8. So that is the first one, boy 3/5, and then girl 5/8. The probability that a girl reaches Form 4 is 2/5. The girl reaches Form 4, so we're going to have another branch here. This is a girl reach Form 4. So for reaching Form 4 I'll use R. Not reaching Form 4 I write R prime. Then for the boy the same thing. So for the boy, reaches, doesn't reach Form 4. So probability of a girl reaching Form 4 is 2 over 5, like that. So not reaching will be 3 over 5. Remember the sum in each branch should be 1. 2/5 plus 3/5, that one should give 1. In every branch you should not have anything less than 1 or greater than 1. So 3/5 plus 5/8, that one should give you 1. Then that of a boy reaching Form 4 is 3/5, so 3/5, so not reaching will be 2/5. Then the other statement, if a girl reaches Form 4, the probability that she gets employed is 2/3 at the probability that she gets employed. So girl, when the girl reaches Form 4, this is the branch, so reaches Form 4, getting employed, I use that. Not getting employed, I use E prime. So the same to this branch here, employed, not employed. Then for also this one, I use employed, not employed. And then this one as well, so employed, not employed. So let me fill these. If a girl reaches Form 4, the probability that she gets employed is 2/3. Reaches Form 4 is given by this branch here. Girl reaches Form 4, the probability she gets employed is 2/3. So 2/3. So not getting employed will be a third. Then while the probability that a girl gets employed without reaching Form 4, is a third. Without reaching Form 4 for a girl is given by this branch R prime. So the probability that she gets employed without reaching Form 4 is a third, so that one will be a third. This one will be 2/3, like that. If a boy reaches Form 4, the probability that he gets employed is 3 over 4. He reaches Form 4 is here, so the probability of getting employed is 3/4. So not getting employed will be a quarter. Then without reaching Form 4 is given by this, so without reaching Form 4 and getting employed is a quarter. So the other one will be 3/4. So that is the complete tree diagram with all the probabilities indicated. So from there you can simply add this one to just help you to work out. This boy reaches Form 4, gets employed. The other one, boy reaches Form 4, doesn't get employed. Then this one, boy doesn't reach Form 4, gets employed. Then this one, boy doesn't reach Form 4, doesn't get employed. For this one, girl reaches Form 4, gets employed. This one, girl reaches Form 4, doesn't get employed. This one, girl doesn't reach Form 4, gets employed. Then this one, girl doesn't reach Form 4, doesn't get employed. So when it is like that, it's going to help you to work it out. Let's go to the questions. Part B, using your tree diagram, determine 1, the probability that a girl gets employed. A girl gets employed. So instances when a girl gets employed is in this branch. So this one is 1. So it is here, gets employed. That is a girl reaches Form 4, gets employed. And then girl doesn't reach Form 4 and gets employed. That is what you're going to use. So those are the two you need to follow. You need to follow these branches very well. So girl reaches Form 4, employed. Girl doesn't reach Form 4, employed. So that one will be given by, so the first one, so we are taking either that GRE or the other one. This is GR prime E. And you know that all, when you have or in probability, or, that means that we're going to add the 2. So the first one is 5/8. Follow that branch. 5/8 times 2/5 times 2/3. Or the other one, which is here, 5/8 times 3/5 times a third, like that. So use a calculator to work out these. So the first one, 5/8 times 2/5 times 2/3, that will give us 6. Then this one will give 5/8 times 3/5 times 1/3. After multiplying and simplifying, that will give an 1/8. And when you add the 2, a 6 plus an 1/8, you get 7 divided by 24. Part 2, the probability that any child who has been to school gets employed. So for this question, the probability that you have been given is for the boy and the girl reaching Form 4. But that does not mean that they never went to school. So they went to school, they have been to school, only that they never reached Form 4. So for this one, when you're getting the probability that any child who has been to school gets employed, it is either the one who finished Form 4 or the other one who didn't finish Form 4. Because by whatever you're given here, the only thing that we have is that they never reached Form 4 or they reached Form 4, but they have been to school. So we are going to take the probability that any child who has been to school gets employed. That means the first one is boy reaching Form 4 gets employed, and a boy doesn't reach Form 4 because he has been to school. Only that he didn't reach Form 4, never reached Form 4, gets employed. That is another one. The girl reaches Form 4, gets employed, and the girl doesn't reach Form 4 and gets employed. So there are these 4 that I've ticked here. So you're going to multiply this branch. This one is 3/8. Sorry, this one is supposed to be 3/8. I wrote 3/5. It's supposed to be 3/8. 3/8. And the boy, the probability that a boy, it is here. 3/8 and 5/8. Supposed to be like that. So we are going to take these branch here. So this is the branch, and then we have this one, 3/8, 3/5, and 1/4. So let me multiply them out. So the first one is 3/8 multiplied by 3/5 multiplied by 3/4. So 3/8 multiplied by 3/5 multiplied by 3/4, or you add the other branch is 3/8 times 2/5 times 1/4. So 3/8 times 2/5 times 1/4, like that. Or the other one is 5/8 times 2/5 times 2/3. So 5/8 times 2/5 times 2/3, like that. Or the other one is 5/8 times 3/5 times 1/3. So 5/8 times 3/5 times 1/3, like that. So that is how anybody who went through the school, only that they never finished Form 4, but they were in school and they got employed. So I'll work out these 3/8 times 3/5 times 3/4 using a calculator and simplify. This will give 27 divided by 160. Then the other one is 3/8 times 2/5 times 4. These are going to give 3/80. Then the other one, 5/8 times 2/5 times 2/3, 1/6. And then 5/8 times 3/5 times 1/3, that is 1/8. This one, when you add it, 27/160 plus 3/80 plus 1/6 plus 1/8, this will give 239 divided by 480, simplified form. We go to part 3. The probability that a boy fails get employment. The boy fails get employment. So the boy fails to get employment. Let's see. So either the boy finishes Form 4, fails to get employment, or the boy doesn't reach Form 4 and also fails to reach to get employment. So those are the two. So you're going to take this branch, 3/8 times 3/5 times 1/4. That is the one that you're going to take. And then 3/8 times 2/5 times 3/4. So we add the 2. So 3/8 times 3/5 times 1/4, or 3/8 times 2/3 to 2/5, 2/5 times 3/4. I've indicated up there how you take those branches. Then 3/8 times 3/5 times 1/4, that gives 9 divided by 160. 3/8 times 2/5 times 3/4, that gives 9/80. And then this one gives 27 divided by 160. We go to the last part. The probability that anybody who has studied up to Form 4 fails get employment. Anybody who has studied up to Form 4. So it is either boy studied up to Form 4, that is reaches Form 4, gets employed, or probability of a girl reaches Form 4 and gets employed. So in this branch here, this is what you're going to take. So boy reaches Form 4, gets employment, then girl reaches Form 4, gets employment. Those are the two you're going to follow. So you're going to take this product, 3/8 times 3/5 times 3/4, or 5/8 times 2/5 times 2/3. That is what you're going to do. So 3/8 times 3/5 times 1/4, or 5/8 times 2/5 times 1/3, like that. And simplifying these, 3/8 times 3/5 times 1/4, this gives 9/160. Then 5/8 times 2/5 times 1/3, that gives 1/12. And this one gives 67/480. So that is how you're supposed to solve that question. Question 19. The diagram below shows a right pyramid, VPQRS, with V as the vertex and a rectangular base PQRS. PQ is equals to 3 centimeters, QR is equals to 4 centimeters, and the height of the pyramid is 6 centimeters. M and N are the midpoints of PQ and QR respectively. So you can see the diagram there. Part A, calculate the length PV. This is a right pyramid. That means that all the slant heights are equal. That is the meaning of right pyramid. All the slant heights are equal. So the moment you get PV, that means it will be the length of all the other slant heights, VS, VR, and VQ. So how do we get PV? Now to get PV, we shall first create the height here. Let's take the height here as so take the height here. So the height there, and then I will draw another diagonal up to the end there. So this height, this point, let me call this point, name it as O. That one meets that at 90 degrees. So now, if we have the height of the pyramid being 6, that is VO is 6, and we have PQ as 3, and then we have QR as 4. So remember, this one is a rectangular based, so meaning all these are right angles, all these are right angles, all these are right angles here. So it is possible to get PR first. PR is going to help us. PR, you consider triangle PQR, that is a right angle triangle, and that one will you use Pythagoras theorem, 3, 4, the other one automatically will be 5, 3:4:5. So PR is 5. And since O is the midpoint, so this means this will be 2.5 and this one will be 2.5. Now to get PV, we shall extract a triangle here, or extract it here. You can see this is what we're going to use. We have O, V, P. So you can see O, V, P. I've extracted that, and having the height here is 6 and having PO as 2.5, I can use Pythagoras theorem to get PV. So PV will be the square root of 6 squared plus 2.5 squared, Pythagoras theorem. And this one will give 6.5 centimeters. So that is PV, 6.5. And remember that now will be the slant height of all the others. Part 2, the angle between phase P, these are VPQ, VPQ and PQRS. That is the angle between two planes, the plane VPQ, VPQ, and the plane PQRS. So to get the angle between two planes, this is what you're going to do. This plane that is here, VPQ, I will simply draw a line, straight line that is perpendicular to that bottom plane. It's perpendicular to this plane here at this point. And then another line passing through O, straight line passing through O to that point. So the angle that I require is this. This will be the angle between the two planes. That is a VPQ. Remember these two lines, this other line is perpendicular. So where this perpendicular line, this perpendicular line to this plane meets the other line, yeah, these are the other plane. This is a V. You can see this line, V up to this point here. So that is the last line and the other line. Where they're intersecting, that is the angle that we require. So we can use this triangle here, you can see, to get the length or the angle between the two planes. So we have the height as 6, and then this length is, the whole of this length is 4. So up to the midpoint here, this will be 2. This will be 2, this will be 2. Because it is the same. This is the same with this 4. So this is the midpoint. So if you extract that triangle, you'll have something like this. That is the angle, that is 6, 90 degrees, and then this one is 2. V is there. So I've extracted it. So you can see it there. So to get the angle, you can use tangent. Tangent will work very well. So tangent of angle theta will be opposite of adjacent. So this will be tan theta is equals to 3. And theta will be the tan inverse of 3. And the tan inverse of 3 will give 70. So the tan inverse of 3, this will give 71 0.57. Need to check the mode of your calculator before you work out questions on trigonometry. So that is what you get. You can go to the other part, B part 1, the slant height VM and VN. The slant height VM. Now we have M and N at the midpoints of PQ and QR respectively. M is the midpoint of PQ. So we have M here. This is a point M. And then the other one is N is the midpoint of QR. So we have it here. This is N. So you're supposed to calculate the slant heights. The first one is here. This is the slant height, VN, and then we have VM. We have it there. Now to get that, to be very easy, since we just need to look at this triangle VPQ. So let me extract that, VPQ. So first one, VPQ. So VPQ, M is here in the center there. So this is where we have M, and we already have PV. PV is 6.5, and also the other slant height VQ is also 6.5. And the midpoint here, since the PQ is 3 and M is the midpoint, so this will be 1.5, this one will be 1.5, this will be 2, this will be 2. So this is 1.5, 1.5. So this one you can simply use, because this one is 90 degrees, that line from V to M is perpendicular, be 90 degrees, it forms a right angle triangle. So VM, we use Pythagoras theorem, because that is a right angle triangle. So this is 6 squared minus 1.5 squared, you get the square root of that. And this will give 6.325 centimeters. So the other one, again, we have to do the same. We have to extract it. We have to extract it as well. So from the other end, now we are using VQR. Remember, the slant heights are equal. They are all 6.5, or the slant height. VQR, N is here, and this is 2, this is 2, this is a 6.5, as you can see. So now getting VN, Pythagoras theorem, because this is a right angle, so VN would be given by the square root of 6.5 squared subtract 2 squared. And that will give 6.185 centimeters. As simple as that. Then the last question, the surface area of the pyramid. The surface area of the pyramid. So to get the surface area of this pyramid, we simply need to get the area of all the faces and then we add them up. How many faces are here? There are 1, 2, 3, 4. There are 5 faces. And for the slant faces, 2 are uniform. Every 2 are uniform. So I want us to start with the bottom face. The bottom face is a rectangle. The area of that rectangle, PQ is 3 and QR is 4. So the bottom plane, the area is length times width. That is a rectangle. So 3 times 4, like that. That is the bottom. Then we add. Now I want you to look at this face. VPQ. You can see that VPQ, already we have extracted it here, so we can use this one. It has been simplified here. So that triangle, you get it by a half times the base. The base is PQ, which is 3 times the height. The height we just obtained is 6.325. And then since we have the other slant height similar one, on the other side, you have to multiply by 2 because there are 2 faces. And then now we have the other face which slants, that is a VQR. Again, we have that. We have that one here. It is here. So again, triangle, that is a half times the base. The base is QR, which is 4, times the height. The height we just obtained is 6.185. And since we have the other face on the other side, the other face, which is a VSP is the other similar face. For VPQ, the other similar face is a VSR. So you multiply by 2. So that is what is going to give you the sum of the surface area. This will give 12. Then this one will give so this is a 3 multiplied by 6.325, and then when you multiply by 2, of course, you know that this one will divide out. So this will be 18.975 plus the other one is 4 multiplied by 6.185. That will give 24.74. When you add everything, plus 18.975 plus 12, that gives 55.715 centimeters squared. Question 20. Two towns A and B lie on the same parallel of latitude 60 degrees north. If the longitude of A and B are 42 degrees west and 29 degrees east respectively, part A, find the distance between A and B in nautical miles along the parallel of latitude. So you're supposed to find the distance between A and B. So first, a rough sketch of these positions that you can identify whether they lie on this. Although we are given they lie on the parallel of latitude, that is a small circle. So they are here, both of them are 60 degrees to the north. And then we have one that is the west. This is 42 degrees west. And then the other one is just a sketch. The other one is 29 degrees east. So we have the two places. A is there, B is there. So this distance along the parallel of latitude, or distance along the small circle. So how do you get that distance in nautical mile? Distance along the parallel of latitude, AB, is given by 60 multiplied by theta times the cosine of alpha, where theta is the longitude difference. So one place is 42 degrees west, the other one is 29 degrees east. So to get the longitude difference, you simply add. So 29 plus 42 degrees, that gives 71 degrees. Then alpha is the latitude angle. And in this case, they are both on the latitude 60 degrees north, so the angle is 60 degrees. So now AB in nautical miles will be given by 60 times the longitude difference, which is 71 degrees, times the cosine of the latitude angle, which is 60 degrees, like that. And this one gives 60 multiplied by 71 multiplied by cosine of 60. That gives 2130 nautical miles. So that is how we're supposed to do that. Part B, find the local time at A if at B is 1 p.m. Longitudes and time. When you're calculating time using longitudes, you need to get the longitude difference. We use longitudes to calculate time. So A is 42 degrees to the west, and B is 29 degrees to the east. And at B it is 1 p.m. So you need to find the time here at A. So first of all, get the longitude difference. The longitude difference already the one that you have already obtained. So the longitude difference will simply be, you add 42 plus 29. We already have that 71 degrees. Then you want to see what difference is brought about by this angle difference or longitude difference. For every 1 degree, there is a difference of 4 minutes in longitudes. So what about 71 degrees? It will be 71 times 4. And this will give 284 minutes. And 284 minutes is equivalent to 4 hours and 44 minutes. So that is the time difference between the two places. After knowing that, now that is the difference in time between A and B. So which one is ahead of time? Places that are to the east of the prime meridian are always ahead of time. Then places to the west are always behind of time. So for A, because that one is to the east of, is to the west of B, A is to the west of B, it should be behind of time by 4 hours 44 minutes. So to get the time at to get the time at A, we simply take the time at B, which is 1 p.m. is the same as 1300 hours. And since A will be behind of time, the time difference is 4 hours. So we subtract 4 hours and 44 minutes. You subtract that. And when you subtract that, you get 0816 hours or 8:16 p.m. and write it like that. Part C, find the distance between A and B in kilometers. The same distance that we calculated in nautical miles, we need to calculate that distance in kilometers. So how do you get distance in kilometers between two places that are on the small circle or the circle of latitude or the parallel of latitude? The distance is given by theta divided by 360 times 2 pi radian cosine of alpha, where theta is the longitude difference. Already we have calculated that. Then 2 times pi, 22/7, times the radius of the earth, which is 6370, times the cosine of the latitude angle, which is 60 degrees. So that is what you're supposed to do there. And this one gives so you have 71 multiplied by 44 times 6370 times cosine of 60, everything divided by 360 and also by 7. So that gives 3948.38 kilometers. Go to the last part. Part D, if C is another town due south of A and 1001 kilometers away from A, find the coordinates of C. C is another town due south, means directly south of A. So if I go to the sketch here, C will be somewhere here, due south, somewhere directly below. So due south means that distance will be the distance along the same longitude, due south, along the same longitude. So we will therefore have the other longitude here. C will move from A and it will be located on a totally different latitude, on a different latitude. So since it is due south of A, so it is directly south of A. That is along the same meridian, along the same longitude, 42 degrees to the west. That is a 42 degrees to the west. So now the other question you need to ask yourself is what kind of distance is this? Distance AC. Distance AC is distance along the meridian or along that longitude, and that is distance along the great circle. Distance along the meridian or distance along the longitude from A to C, that is distance along the great circle. And we have been given that distance is 1001 kilometers. So that distance AC, you get it by, how do you get distance along the great circle? In kilometers. It is theta over 360 times 2 pi r. That is how we get that. And in this case, theta will be the latitude difference. Latitude difference. Because these two places, A and C, these two places, A and C, are located on the same longitude, but now they will be on different latitudes. The same longitude, 42 degrees west, because it moved just due south of A. So what we need to do here is to know that theta will be the latitude difference. So AC, the distance is 1001, is equivalent to latitude difference divided by 60 times 2 times 22/7 times the radius of the Earth, 6370. So just make theta the subject. Make theta the subject. So theta will be given by 1001 times 7 times 360. You're making it the subject, times 2 times 22 times 6370. And you notice that when you work out this one using a calculator, 1001 times 7 times 360 divided by 22 times 2 times 6370, you get 9 degrees. So 9 degrees is the latitude difference. Latitude difference. So now, because that is the latitude difference, and you get it by subtracting or adding. So when you look at the latitude of A is 60 degrees north. So place A is 60 degrees north and 42 degrees west. C, we said C will be located on either X degrees. We don't know whether it is north or south. We want to determine that, but on the same longitude. So how do you get this difference? By subtracting either these and these. So when you try to work out using the two scenarios, you know whether it will be to the north or to the south. So if, for example, you take, you want to get the difference, and you want to take 60 plus X, that is the latitude difference, it should give you 9. Will that one work? And when you add it like that, when you add 60 plus X, you assume that one is to the north, so C will be to the south. So you must add together. So you notice that this one is not going to be applicable since you're going to get a negative value for X. So that means C is not located to the south. It is to the north. To the north, and that is why when you take the difference now, 60 degrees subtract X should give you 9. Like that. So that now, when you work out these, you notice this will be negative X is equals to negative 51. And you will get X to be positive 51 degrees. So that means that this place here, X, will be 51 degrees to the north. When both of them are to the north, you get the latitude difference by subtracting, and that is what I've used. So that is simply how you're supposed to solve that question. Question 21. The table below shows the marks scored by students in a mathematics test. So you have the marks, you have the number of students. Draw a cumulative frequency curve, also known as the 𝐏𝐏 curve, to represent the information. Now, to draw the cumulative frequency curve, we plot cumulative frequency against the upper class boundaries. So we need to identify first the cumulative frequency. I'll write them against here. So the first cumulative frequency, 2. We use red. So this is 2. Then 2 plus 3, you get, this is 5. 5 plus 8, you get 13. 13 plus 12, you get 25. Then 25 plus 15, you get 40. 40 plus 6, you get 46. And then 6 plus 4, you get 50. So in all the classes, you have the cumulative frequency there. And now we need the upper class boundaries. Class boundary. The first one is first class from 30 to 39. Upper class boundary there is 39.5. The other class 49.5. The other one 59.5. The other one 69.5, 79.5, 89.5, 99.5. So don't need to write that one. So because already have, you know it. So let me go straight to the graph. Go straight to the graph. So I've drawn the X and the Y axis. The scale that I'm going to use, let me use for the Y axis, for the cumulative frequency, I can use 5. 1 centimeter represent 5. This is 15, 20, 25, 30, 35, 40, 45, 50. See, the last one is 50, so it's okay. So this is the cumulative frequency representing the number of students. So this is the number of students. Then the upper class, the max, this will be the max, the x-axis. We have the max, we use the upper class boundary. So we can, because the first upper class boundary is 39.5, we can start a little bit lower. So we start with the lower class boundary of that class, 29.5. So I can start with 29.5, let's say 29.5 will be there. And then I will use 2 centimeters to represent 10. So from 29.5, I have 39.5, 49.5, 50.5, 60.5, 70.5, 80.5, then 90.5, and the last one 99.5. It is fitting almost out, so it's okay the way it is. So it is quite okay. So 29, 39, 49, 59. This is 59.5, 69.5, 79. I wrote 80.5, 99.5 is supposed to be, the last one here is supposed to be 99.5. So this is 29.5, 39.5, 49.5, 59.5, 69.5, 79.5. This is 89.5, 99.5 is okay. Now from there, now we can plot. So the first one, 39.5 for this class, 2. 39.5. 2 is there. The other one is 49.55. Then the next one is 59.513. Then 69.525. Then 79.540. Then 89.546, 89.546 is there. And then the last one, 99.550. So from there you can draw the curve using smooth curve, join these points using a smooth curve. This is okay. Then after you've drawn that, to ensure that your curve is not hanging, ensure that all the points, the curve passes through all the points that you have indicated there. So you have to anchor your curve here by joining it straight to, don't leave it hanging, straight to the start point here, starting point like that. So that is the cumulative frequency curve. Then let's go to the questions. For this one, you get a mark for the correct scale, the correct curve, drawn smooth curve, and then for the plotting you get a mark. Then you, because you can see there's a 4 marks, you get a mark here for the cumulative frequency curve. Now from there, the median. So how do you get the median? Now to get the median, it is half. The position of the median is given by half times the total frequency. Total frequency is 50, so we get that from the 25th student. The 25th student. So we identify the 25th student is here. So draw a straight line. The 25th student is here. So draw a straight line. Straight line from 25th student up to the point where it touches the curve. That is the point touches the curve. Then straight down, and this will give the solution. This will be the solution for that. And this one gives 69.5. So median is given by 69.5. Then we come to the other one, the quartile deviation. Quartile deviation is given by the average of the quartiles. Q3 subtract Q1 divided by 2, also known as the semi-interquartile range. So for this one, we have to identify Q3. So Q3 is the upper quartile. The position of Q3 is 3/4 times the total frequency. And this will give us the position as, work it out, this will give 22.5. This is going to give 37.5 position. That is a position, 37.5. So we go directly to 37.5. So 37.5 is somewhere here. This is 36, 37, 37.5 will be, so this is 36, 37. So 37.5 will be somewhere in the middle there, somewhere in the middle. And then you, from that point touches the curve, you drop down, straight down, like that. So 37.5 is here. So draw a straight line up to the point where it touches the curve, straight down. So this gives, the size of one small square here is 1. So we have 9, at least 9. So 69.5. 69.5 plus 9. So 69.5. Then you add 9 small squares. There are 9 small squares. Around the 9, not 9. And see, these are 1, 2, 3, 4, 5, 6, 7, 8. There are 8. There are 8. Around 8, because I can see it has slightly gone beyond. So it will be around 8.5. That will be around 8.5. 8.5. This will give 78. Those who get 77.5, a slight allowance is allowed. 77.5 is allowed. So mine is 78. Then Q1 is a quarter of the total frequency, quarter over 50. So we get the position, quarter over 50 is at 12.5. That is a position, 12.5. So 12.5 is somewhere here. 12.5 is somewhere there. So we have 11, 12, 12.5 is around there, somewhere there. Just estimate that. And then you drop straight down. Drop straight down. So 12.5 is here. The straight where it touches the curve. So I read this value. So you can see here from 49.5, these are around 9.5. So I'm going to add 9.5. So from 49.5, yeah, I add around 9.5. It is not yet 9, it is past 9. So add 9.5. These will be 59. Mine gives 59. So this one gives 59. So now having the upper quartile as 78 and the lower quartile as 59, now we can get the quartile deviation by taking Q3, we got it as 78, subtract Q1, which is 59, then you get the average of that. This one will give you 9 point, you get 9.5, the solution. We go to the other part, that is a quartile deviation, part 3 now. The pass mark if 60% of the students passed. So how do we get that? The pass mark if the 60% of the student passed. So if 60% of the student passed, how many failed? 40% the students. 40 over 100, 40% of 50 students. Those are the ones that failed. So that means 20 students failed. If 20 students failed, then the first student to pass was the 21st student, and the 21st student being the first pass will give us the pass mark. It will give us the pass mark. So we go to 21st student, the 21st student, we get the mark that he got. So the 21st student is here. This is the 21st student there. So it goes straight to the point where it touches the curve. And then from this point, we drop down. There. So that will give us the mark using a thick line. So that is why I told you that I may have slight answers that are different from yours. So the 21st student is here. So draw a straight line up to the point where it touches the curve, then drop down. So this one will give, how many squares are these? These are 5, 6, around 6.5. Estimate they're 6.5. So these are 6.5, around there. So 59, that will give 59. 59.5 plus around 6.5. So these will be, pass mark will be 66. The pass mark will be 66. So this point here, the 21st student was the first one to pass. So the pass mark probably could be 66. So this is a 66. So the pass mark is 66 marks. 65, 66.5 is okay. Slight allowance is always given for graph work. And that is how you're supposed to solve that question. Question 22. The initial velocity of a particle was 1 meter per second and its acceleration is given by 2 minus t meters per second squared every second after the start. Part A, 1. Determine the equation representing its velocity. The equation representing its velocity. So what you're given is acceleration, and you're supposed to use acceleration to get velocity. So how do you do this? One thing you're supposed to remember, when you have displacement, you differentiate displacement to get velocity. You differentiate velocity to get acceleration. That is the downward movement. You differentiate. For any downward movement, you differentiate. Then for any upward movement, for instance, you given acceleration, like in this case, and you're required to get velocity. So that is upward movement, you have to integrate. So for you to get velocity, you shall integrate acceleration with respect to time t. Again, in case you're given velocity and you're supposed to get displacement, you'd integrate velocity to get displacement s. So for upward movement here, you integrate. So we have velocity will be given by, we take acceleration. Acceleration is 2 minus t like that. So we're going to integrate that with respect to t. So velocity will be given by, when you integrate 2, you get 2t with respect to t. When you integrate negative t, you get negative t squared divided by 2, then plus the constant of integration. Now after that, you need to get the constant of integration, and that one, because you have been given initial velocity, the initial velocity is 1, and at initial velocity, time will be 0 seconds. So you need to substitute v is equals to 1 and t is equals to 0 in this equation for velocity to get c. So v, which is 1, is given by 2, t is 0, minus, we have 0 squared, that is t squared, divided by 2, like that, plus c. So you notice that c will be given by 1. And therefore, now the equation for velocity will be v is equals to 2t minus t squared divided by 2 plus 1. That is the equation representing the velocity. Part 2, find the velocity of the particle during the third second. So during the third second means you will get the velocity from the second to the third second. That is what you're supposed to know. So the same way, what I'm going to do, there are two ways. You can take that velocity and then you substitute 3, you get the velocity, and then you substitute 2, you get the velocity, and then you get the difference of the two. Or you can simply use what we had here. Remember, to get velocity, we say do you integrate. So you're going to integrate now from 2 to 3. You integrate acceleration, which is given by 2 subtract t with respect to t. So this will give 2t minus t squared divided by 2 plus c. So you not use this where we got the constant as 1, because that was giving us velocity directly. And I've said there are two methods of doing this. So I'm just using another alternative method. Then the square brackets from 2 to 3. So you simply substitute these. So you'll get substitute 3, t is equals to 3 minus 3 squared divided by 2 plus c, minus substitute 2, t is equals to 2, so this will be 2, t is equals to minus 2, this t is 2 squared divided by 2 plus c, like that. So once you've done that, there's something that you notice here. C will get subtracted, and therefore it will be 0. So now you shall remain with, on this side you have 6, subtract, this is 9 divided by 2, that will be negative 4.5. And then for c, of course, c will get subtracted. So that is what you shall have, because c will get subtracted when you open the bracket. So this one will get subtracted. So you have these, that is 6, and then 3 squared over 2, 4.5. So this one, you can work out that one. So that one will give you 1.5. Now let us work out this one. 2 times 2, you get, that is 4, subtract, this will give 2. So for this one, you'll get 2. You get 2 like that. So now you subtract the 2. So 1.5 subtract 2, that will give negative 0.5. And this is the velocity. So it is meters per second. B1, find the equation representing its distance t after the start. So you require to get the distance. So let me take you back here. So now, how do you get distance? So already you have velocity. So and you need distance, which is displacement here. So you will integrate velocity in order to get distance. Integrate, that is upward movement. So integrate velocity to get distance. So distance will be given by, you integrate velocity with respect to t. So distance will be given by, so velocity, we have the equation for velocity, t is up there. So this is 2t minus t t squared divided by 2 plus 1 with respect to t, like that. So when you integrate these, you get these will be 2t squared divided by, when you integrate 2t, you will get 2t squared divided by 2, which will give t squared. Now you're getting distance. When you integrate t squared divided by 2, you get t cubed divided by 6. When you integrate 1, you get t, then plus the constant of integration. Now once you do that, remember after the start, t of course was 0. Start with this 0, t is equals to 0. And then of course when you're beginning, also distance will be 0. That is when you're beginning at the start. So now you shall substitute these. So you shall substitute these, t is equals to 0 and s is equals to 0 in this equation for distance. So, and this one, when you substitute t is 0 here and s is 0, you remain with c to be 0. So c will be 0. And therefore, the equation representing distance will be given by t squared minus t cubed divided by 6 plus t plus 0. So you can just leave it the way it is. We go to part 2. What was the distance covered by the particle during the first 3 seconds? During the first 3 seconds. So during the first 3 seconds, you want to get the distance. So you simply start from here. So remember, this is the distance, this is how you get distance. So you should say distance is equals to, you now get from the first 3 seconds, means from 0 to 3 seconds. So you have 2t minus t squared divided by 2 plus 1. So this is still another method. You can take this equation for distance and then you simply substitute with t with 3. It will give you directly the answer, because you want the distance from the first, from 0 to 3. So whichever works, I will still do using the other method. Show you that. So this one will give you square bracket. So when you integrate these, you get t squared minus t cubed divided by 6 plus t plus c. So from 0 to 3. So substitute 3, t is equals to, so this will be 3 squared minus 3 cubed divided by 6 plus 3. Then everything here, when you substitute 0 here, it will be 0. C will get subtracted. And this one gives you 3 squared is 9. And then subtract 27 over 6 plus 3. So this will give 7.5 meters. 7.5 meters. So alternatively, because you're getting the distance, you can take s is equals to, you simply from 0 to 3 seconds, that is the first 3 seconds. So you just take t squared, which is 3, substitute t with 3 squared minus, this will be 3 cubed 27 divided by 6 plus 3, which will still give you 7.5 meters. So part C, determine the time when the particle was momentarily at rest. So when is the particle momentarily at rest? And how do you know about that? When the particle is momentarily at rest, velocity at that instance is equivalent to 0. So we shall take the equation for velocity and then we equate velocity with 0. This is here the equation for velocity. Is here v is equals to 2t. So v is equals to 2t plus t squared divided by 2 is minus plus 1. It is minus, then plus 1. So this is minus, then plus 1. So we shall equate v with 0. So we shall have 2t minus t squared divided by 2 plus 1 is equals to the velocity, which is 0 when the particle is momentarily at rest. So from there, I can reorganize this one to form a quadratic equation, and I will first eliminate this denominator by multiplying each term by 2. Multiply each term by 2. so that I have 4t minus t squared plus 2 is equals to 0. If I reorganize this, I will have negative t squared plus 4t plus 2 is equals to 0. Multiplying each term by negative 1, get t squared minus 4t minus 2 is equals to 0. So from here, you can use the quadratic formula, the easy one, in order to actually come up with the values of t. So the quadratic formula t is given by negative b plus or minus, we have b squared minus 4ac divided by 2a, where a will be the coefficient of t squared is 1, b will be the coefficient of t, which will be negative 4, and c will be the constant negative 2. So substitute that one here, and this is what you're going to have. Negative b is negative 4, that will be 4 plus or minus. We have b squared, negative 4 squared will give 16 minus 4 times a is 1, times c, which is negative 2. Everything divided by 2 times a is 1. So that one will be 2, like that. Then from there we have 4 plus or minus, whatever is in the bracket there. So we have, this will give us 16 minus negative 8. So that will be root of 24. And then divided by 2. So we get the root of 24. So the root of 24 will be 4.899, like that, divided by 2. So at this stage, you can only consider the one that will give us a positive time. You consider the positive only when you're getting time. Time is a scalar, so you ignore the negative time. So the one that will give us positive time will be 4 plus 4.899. Then you divide by 2. When you use the 4 subtract 4, that will give us negative. So that will not go very well with time. So I add these. So this will be 8.899. We divide by 2. And this will give t to be 4.9449 seconds. That is the time when the particle was momentarily at rest. Question 23. Part A. Using trapezoidal rule, estimate the area bounded by the curve y is equals to 3x squared minus 2, and the lines x is equals to negative 4, x is equals to 4, and the x-axis using 8 trapezia. You're supposed to use the trapezoidal rule. So the first thing, you're given the range from negative 4 to 4. So prepare a table of values all the way from x is equals to negative 4 to x is equals to 4. So from negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, up to 4. So this is x, and then you have the y. So you're using this equation, you're simply using the calculator to work out these. Use a calculator to work out these. So you're using this function, so y is equals to 3x squared minus 2. Let's fill this table. So when x is -4, you substitute in this function, you'll get y to be 46. When it is -3, you get this one will be 25. When x is -2, get this one as 10. When x is -1, get this one to be 1. When x is 0, this will be -2. When x is 1, get 1. When x is 2, get 10. When x is 3, get 25. When x is 4, you get 46. Then now we use the trapezoidal rule. The trapezoidal rule states that area is given by half multiplied by the height, half height. Then we have the first height of the strip of the trapezia plus the last one, height of the trapezium, plus twice all the others, the middle one, y1 plus y2 plus all these up to the end. That. So in this case, we have the height. Height is 1 from -4 to -3 to -2. You can see the height is uniform. It is 1. 1 will not make any difference. Then y0 is the first height of the trapezia, which is 46. And yn is the last one, 46. Then plus twice all the other middle values that remained from x is equals to the first one is 25. Get the sum plus 10 plus 1 plus -2. But you're not going to consider -2 because this is the height of the trapezia. You consider the absolute value, which is 2, not -2, is the height of the trapeze, that is the length, plus 1 plus 10 plus 25, all the middles. Then you close the bracket. So this will give half. This will give 92, 46 plus 46. And then the other one, 2 into brackets, just feed it in your calculator. 25 all the way to 25, you add that will give you 148. 148. This will give half times 92 plus 148, that will give 240. And when you work it out, area, half of 240, that will give you 120 square units. That is the area using trapezoidal rule. Part B. Find the actual area bounded by the curve. The lines x is equals to -4, x is equals to 4, and the x-axis. The actual area is obtained by integration. You get the actual area by integration. So to do this, because you have a range from -4 to 4, it is good to sketch this curve so that we may know how does it look like. How is that curve? So we are going to be guided by this is when you look at the values again here, when you look at these values you filled, and also if you want to know where this curve cuts the x-axis, the curve is y is equals to 3x squared minus 2. You can simply equate y to 0, so that you have 0 is equals to 3x squared minus 2. If you want to know why it cuts the x-axis, it cuts the x-axis at points where y is equals to 0, the y coordinate. So this will give, x will definitely give the square root of 2/3. The square root of 2/3, and the square root of 2/3 will be plus or minus 0.82, around there, 0.82. So these are the points. So if you do a rough sketch of this curve, you notice it looks like this. That is the y, this is the x. So assuming that this is a 46, the point from what you have here, you can see -4 y is 46. Then at 4, when x is 4, y is 46. And then when x is 0, y is -2. So I can use that one to guide me. So -2 is here, 0 is there. And then I have -4 to 4. So if I was to sketch this one, you notice that it looks something like that. So that is what you notice. And okay, there's something I've not indicated clear. So there are points that I wanted to give before I do that. I have not indicated these values. It casts the x-axis at point 0.82 and -0.82. These two. So we can put it at this point. This is -0.82, and then you have positive 0.82. So that curve, now if I am to draw it, just a sketch. This is just a sketch. Probably it looks something like this, like that. So you can see why it cuts these are the values. It cuts the x-axis at these 2 points, -0.82, positive that. But we require the area, remember we require the area up that bounded by these lines here that I'm trying to indicate here. And extend it a little bit there. And remember that this is just a sketch to help me work out these. Just a sketch. So this is where we have 4. So we are getting the area bounded by this curve and the lines x is equals to -4 and x is equals to 4. So let me shade that area so that you can see it. So the area we want is that bounded by the x-axis and the lines, x is equals to 4 and x is equals to -4. So that is what you're supposed to get. And work out this one. We will need to have, using integration, we're going to integrate from -4 to -0.82. So integrate from -4 to -0.82, 3x squared minus 2, that, and then we add now from -0.82, now from here to here, from -0.82 to 0.82. 0.82, like that. 3x squared minus 2 with respect to t, and then plus the other one from 0.82 to 4. From 0.82 to 4. To 4. Like that. So that is the area that we need to get. And this one that we will not do twice, because I want you to notice something here, that this particular area that is here, this one that is on this side, it is similar to this. So I just need to get 1 and then I multiply by 2. So I can either get this one, can either decide to get this and then I multiply by 2, or probably I use this one. So whichever works. This is the same with this. So I just get 1, I multiply by 2, and then I will add this. So let me start by getting this. So starting with this one. So that one will give, when you integrate this, 3x squared, when you integrate to be x cubed, that will give x cubed. X cubed height is okay. Then minus 2t plus c. Like that. Then from -4 to -0.82. need to be very keen when you're substituting this one. So this one will give, when you substitute negative 0.82, you get negative 0.82 cubed minus 2 negative 0.82. I will not add the constant because it will get subtracted. Then you substitute negative 4. So negative 4 cubed minus 2 negative 4. Like that. So this one will give, negative 0.55 plus 2 multiplied by this will give 1.64. Subtract negative 4 cubed, that will give negative 64. Then negative 2 times negative 4, that is 8, positive 8. So this will give positive 1.09. Subtract, this will be negative 56, so it will be plus 56. When you open the bracket, subtract negative 56, so it will be positive 56. And this one will give 57.09. Now, since this area, remember the same, this one, we said this one will be the same with this. So we just get 1 and multiply by 2. And you could see that from the diagram. They are the same. So we multiply this one by 2. When you multiply that one by 2, 57.09, that will give 114.18. So we are not yet through. So now we are remaining with the other one. We are remaining with this one now, the one that is at the middle, this one. We are remaining with the one that is at the middle, this one, from negative 0.82 to 0.82. So we get that. So that one I can work it out separately here. So we're integrating from negative 0.82 to 0.82, 3x squared minus 2 with respect to t. So for this one, I'll integrate this one very fast. So we shall have, we substitute. So when we integrate this, you get x cubed minus 2x plus c, square bracket, negative 0.82 to 0.82, like that. And this one will give, when you substitute 0.82, shall get 0.82 cubed minus 2 to 0.82. Then subtract, we substitute negative 0.82, negative 0.82 cubed with the brackets, don't forget to do that, negative 0.82, like that. And these will give, when you work out these, you get 0.55, subtract 1.64, then this will give negative 0.55 plus 1.64. So once we subtract this 0.55, subtract 1.64, this will give negative 1.09. Then the other one will be, when you subtract these will be positive 1.09. Whatever is in the bracket here will be positive. So that negative times positive is negative. So this will give, because you want to consider the absolute value, you're going to take the absolute value. We ignore the negative. The negative only shows that the area is below the x-axis, of which you can see from the diagram. So this will give 2.18. So now after getting that, we have the three areas. So now we get the sum, the total area. The two areas, one to the left and the other one to the right, was given by 114. We multiplied by 2 to get 114.18. Then we add the one that is at the middle, 2.18. Plus 1 plus 2.18. So this gives 116.36 square units. So that is how you get the area, the actual area by integration. So you need to be very keen when you're integrating. Don't integrate directly from -4 to 4. First, check where the curve cuts the x-axis like we've done in this part. Once you've done that, you'll be able to see which exact area that you're supposed to calculate. Like you can see there, you have this section, this one, and this one, of which you've said this one is the same with this. So that is all that part. Now we can proceed to the other part. The last part is calculate the percentage error when using the trapezoidal rule. So the error, already we got, with the trapezoidal rule, we got 120. So 120. And using the integration, the actual area. The actual area is 116. Remember, we take the absolute. So if you decide to take the actual, subtract the trapezoidal, only consider the positive. So 120, this is the error, 120, then subtract 116.36. That will give us the error. That will be the error. So 120 subtract 116.36, you get the error as 3.64. So percentage error is given by the error 3.64 divided by the actual area. The actual area is the area given by integration method, like that, and then you multiply by 100. So divide by 116.36, and then you multiply that by 100. So this gives 3 point. You get a percentage of 3.128%. Remember always to leave your answer correct for significant figures, unless advised otherwise. All right, so that is how you're supposed to solve that part. Question 24. The vertices of triangle PQR are, they're given there, P, Q, and R, they're given. A transformation represented by a matrix T, -1, 0, 0, 1, maps triangle PQR onto P prime, Q prime, R prime. Second transformation represented by U, which is 1, 0, 0, -1, maps triangle P prime, Q prime, R prime onto triangle P double prime, Q double prime, R double prime. Part A, on the same axis, draw the three triangles and state the coordinates. Of triangle P prime, Q prime, R prime, and P double prime, Q double prime, and R double prime. So that is the question. We start with getting the images. So we have two transformations, and this is what I'm going to do. So the first one, it is represented by matrix T. So T transforms triangle PQR into P prime, Q prime, R prime. So we need to multiply that. So the matrix T, -1, 0, -1, 0, 0, 1. That is matrix T. That is the one that maps triangle PQR to P prime, Q prime, and R prime, like that. So P is 1, 1, then the next one 4, 1, and 5, 4. So these will give us the first image. So should be versatile with the multiplication of this matrix. matrices, 2 by 2. These are 2 by 2 multiplied by 2 by 3. So ensure that the matrix of transformation should always be pre-multiplied. It should come before, like the way I've indicated T there. So when you multiply these, you will get -1, -4, -5. Then row 2, you get 1, 1, and 4. Now, after getting that image, again, it is transformed by the second transformation, which is U, 1, 0, 0, -1, 1, 0, 0, -1, like that. Now, these are P prime, Q prime, and R prime. And this is the one that will give P double prime, Q double prime, and R double prime, like that. So these are -1, 1, -4, 1, -5, 4. So this is matrix U. So when you multiply these, you should get -1, -4, -5. And then this one is -1, -1, -4. You multiply that. So now you have the images, they are there. So now we need to plot the 3. So we go to the graph. Let's go to the graph and plot these. Go to the graph and plot these. Start by drawing the axes. So the axes are here. Let me put them clearly. So those are the axes. So the x-axis, you have the y-axis. So this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Then -1, -2, -3. You should have looked at these values to ensure that your scale, the way you draw the axis, everything will fit there. By looking at the coordinates of each triangle. So we start with the image. Although we have everything here on the other side. So PQR, P is 1, 1. So 1, 1. That is P. Then we have Q is negative. Now Q is 4, 1. 4, 1. This is Q, 4, 1. And then we have 5, 4. 5, 4. That is R. So now you can join these points. Make sure you label your triangle. When it is not labeled, you lose a mark for that. Sure that the triangle is well labeled. So there it is. So you have P, we have Q, we have R. Now we go to the first image, P prime, Q prime, R prime. -1, P prime is -1, 1. -1, -1, 1. That is P prime. And then you have -4, 1. That is Q prime. And then you have -5, 4. That is Q prime. We join that again. Join these points. Like that. Then the other one, the third one, P double prime, Q double prime, R double prime. P double prime is negative 1, 1. Negative 1, 1. Negative 1, negative 1. I mean, negative 1, negative 1. Easier. Check the scale. The way I wrote the scale. So negative 1 is supposed to be there. Negative 2, negative 3, negative 4, negative 5, negative 6. So negative 1, 1 supposed to be there. So that is P double prime. And then Q double prime, negative 4, negative 1, negative 4, negative 1. So that is Q double prime. And then R double prime, negative 5, negative 4, negative 5, negative 4, Q double prime. So join these points once again. So you have all the 3 triangles and they should all be labeled clearly. All the points are supposed to be there. So let me go to the other question. So after that question, you are supposed to state the coordinates. You're supposed to state the coordinates of P prime, Q prime, R prime, and P double prime, Q double prime. So the coordinates, let us state them. So the coordinates are as follows. So we have P prime. P prime is here. That was negative 1, 1. And then Q prime. Q prime is negative 4, 1. R prime is negative 5, 4. Then P double prime. P double prime is negative 1, negative 1. Q double prime is negative 4, negative 1. R double prime is negative 5, negative 4. That is how you're supposed to leave the coordinates. Now we proceed to the other question. The other question which was there, I think that one is, let me check whether it is somewhere here. Actually, it is here, the last part. It is here on the last part. So you're supposed to, zoom this. You're supposed to describe a single transformation which maps triangle PQR onto triangle P double prime, Q double prime, R double prime. So let's go to the figure. So this is what you're supposed to, this one being the object and this one being the image. So the transformation that maps, the transformation that is going to map this one onto this. So look at these 2 triangles, PQR and P double prime, Q double prime, R double prime. Just think of all the transformation that we have. We have enlargement. This one doesn't look like an enlargement because when you look at even the points like, look at P. P is there, yes, and that our reflection can work. But now when you look at the other point R, and where is R? I think I omitted R. R is supposed to be R double negative 5, negative 4. This is R. This is R double prime. Then Q negative 4, negative, that is okay. So look at R. I'm trying to look at them. For a reflection, you will notice that, for a reflection, the properties of reflection, the point and the object point and the image point are directly opposite each other. But in this case, when I look at Q and this one, not yet. That one doesn't look like one. It isn't, you can see this one is like, it has been rotated. When you look at these points, like Q, see where Q is, and then look at the Q double prime, where it is. That is rotation. Then look at R. Okay, then look at these. So I'm trying to look at it, and for reflection, it may not work because of this point, these and these. Q, P, and P cannot, but this one, but Q has moved. So these are some sort of rotation. When you look at these points, look at where, especially where Q is, and look at where Q is, and look at this one. Seems to be a rotation. P, this one can be a rotation. And having ruled out all the other transformation like reflection, translation, you can see when you look at these points that these are probably a rotation. And for rotation, you must have the center for you to describe it, and the angle. So how do you get the center? Now we're going to do some construction, because we must have an angle, common angle of rotation. So let's see with one. So for us to do that, to determine the center and the angle of rotation, first you join image point and object point using a straight line. I will use, for instance, let me use Q. I can join Q to, these are Q to Q double prime, like that. So let me join that. So when I join the two, so I join Q and Q double prime. You can choose any other. So I've joined Q and Q double prime. You can choose P and P double prime, R and R double prime. Any can work. So when I construct a perpendicular bisector of that line, Q double prime, this is how you construct it. You stand at Q, the pair of compass stretched more than half of that line. You mark an arc there, and then down here, you mark an arc. And then from here, you stand at the same measurement. You stand at Q double prime. So you cut this arc, cut that arc, and then for the other arc here, make sure you cut it as well. Then from there, you join the point of intersection of these arcs using a straight line, like that. You join it using a straight line is like that. It is okay. And then you can join another point. So let me go with R. I can join another one. So I joined, the one that I've joined is Q and Q double prime. And I've constructed the perpendicular bisector of that. So Q and Q double prime, perpendicular bisector is there. Take another point, and I will take R. I join R to R double prime. R to R double prime. Then construct perpendicular bisector of that one as well. So stretch your pair of compass more than half of that line. So standing at R, mark an arc there, big arc, and then mark another arc here, like that. Then with the same measurement, I go to R, I cut that arc, and then I also cut the other arc. So check the points of intersection so don't confuse. So this point and this point here, you join those 2 points using a straight line. Join those points using a straight line. There it is. So now I would like you to check, where are the two perpendicular bisectors meeting? So that perpendicular bisector is here, and then the other perpendicular bisector was here. The other perpendicular bisector was here. First here, the perpendicular bisector of Q double prime and Q, perpendicular bisector of R double prime, they all meet at these. So where the two perpendicular bisectors meet, that is definitely the center of rotation. That is the center of rotation. So now after getting the center of rotation, we want to get the angle. So the center of rotation is the origin, 0, 0. They are meeting here. So to get the angle, you measure the angle from the object to the image. From the object to the image. The object is PQR. So you measure. So I'll measure, for example, just pick any of the object. Like now I want to take P, not P, but I can use the one that I've already joined. Let me use a Q, this line Q to Q double prime. So I place my protractor along that line. So there it is. So you can see I've placed it. It is there along that line. You can see it there. So you measure the angle from this end, from the object to the image. So you can see this is a straight line. So that angle, you measure it through the center. Center is here. So you find that is 180. It is a straight line from here all the way. That is 180. And also the other way around, it can also apply. So that is anti-clockwise. Anti-clockwise is negative 180. And also when you place it like this will also work. When you place it the other way around like this, also that one will work, because you measure it now from in a clockwise direction like this. So that one will still work. From the object point Q to Q double prime. So you can see that. So that is exactly 180. So we're going to describe this and say, describe it fully. We simply say that this is a rotation, and with center as the origin, 0, 0, and the angle through an angle of positive or negative 180 degrees. So that is how you describe a rotation fully, by giving the center of rotation and also the angle of rotation. So that is basically how you're supposed to solve that question.